Hello everyone, happy to see you here. Welcome back to my channel. Hi, I'm Mathematics. Today we have very tricky and I would say really interesting question from entrance examination. We have in our numerator square root of 25. We divide it by square root of 10 minus square root of 5, and we need to raise all this expression to the power 10. So if you have your solution, your answer, you can also write it in the comments below and then we will check our answers. Okay, so let's start. First of all, let's rewrite our expression and let's simplify this expression in parentheses. So as a result, we have square root of 25 in our numerator. We divide it by square root of 10 minus square root of 5. And we raise this to the power 10. Right now, square root of 25, of course, equal to 5. But in our question, let's write it as square root of 5 times square root of 5. Let's write it like that. And we divide all of this by square root of 2 times square root of 5. So instead of this square root of 10, let's write this product, square root of 2 times square root of 5, and minus square root of 5 from here, minus square root of 5 from here, and raise all of this to the power 10 equal to. Okay, right now in our denominator, let's factor this square root of 5. So we have the same numerator, square root of 5 times square root of 5, and we divide it by square root of 5, so we factor it, and in parentheses we have square root of 2 from here, so square root of 2 minus square root of 5. When we factor it, we have only 1, so minus 1, and raised to the power 10. Great, what we're gonna do next? Right now, we can easily cancel this square root of 5. Yeah, we can cancel one square root of 5 from here and square root of 5 from here. As a result, we have square root of 5 in our numerator. So we have square root of 5 in our numerator. And in our denominator, we have square root of 2 minus square root of 2 minus 1. And of course, all raised to the power 10. Great, what are we going to do next? Right now, of course, when we have a fraction and we raise to the power, for example, 10, we need to raise our numerator to the power 10, so square root of 5 to the power 10, and our denominator to the power 10, so square root of 2 minus 1, raised to the power 10. Right now, without any problems, we can simplify our expression from here, so square root of 5 to the power 10, because this is equal to 5 to the power 5, 5 to the power 5. And we erase all of this, when we divide all of this, by square root of 2 minus 1 to the power 10. And the last step, because 5 to the power 5, this is our table case, equal to 3125 over square root of 2 minus 1 to the power 10. Okay, if you look closely, we simplify our numerator, so we don't have a power, we have a basic constant, but in our denominator we still have this power 10. So right now, as a next step, let's try to evaluate, let's try to simplify this expression in our denominator, and then we will plug in that expression into this spot. So let's rewrite it, square root of 2 minus 1, square root of 2 minus 1 to the power 10. We need to evaluate it, we need to simplify it. So right now we have to find the method. How can we do this? My quick recommendation, so this is my solution, let square root of 2 minus 1, let's write that this is equal to x. Okay, so for example, this expression is our x. So we have to find x to the power 10, yeah, because this is equal to x, so x to the power 10 expression that we need to find. So right now, just look closely at these few manipulations. So I'm going to do right now. So first of all, let's change positions. So x equal to square root of 2 minus 1. Let's change position. So this one on the right side, this one on the left side. Secondly, let's add 1 to both sides. As a result, we have x plus 1 equal to square root of 2. We just add 1 to both sides. I can easily underline that what we did. We add 1 to both sides, and right now let's raise both sides to the second power. So let's square our both sides. On the left side, we have x plus 1 to the second power equal to square root of 2 to the second power. As a result, we can easily cancel this square root sign with this 2, so we have 2 on the right side. On the left side, we have a basic school identity, x squared plus 2x and plus 1 equal to, from here we have 2. Right now I'm going to continue right here because I don't have enough space. So what we're going to do next? We're going to subtract 2 from both sides, x squared plus 2x plus 1 and minus 2, and of course equal to 0. And right now we can simplify, we can evaluate this expression, we can subtract it, so we have x squared plus 2x and minus 1 equal to 0. And of course this is a quadratic equation, but we don't need to solve it. We need to express from here our x squared. So x squared equal to 1 minus 2x. And this is the key expression for us, extremely important expression, because right now it's extremely helpful for us to have this expression with x squared, because we need to find x to the power 10. We need to solve it for x to the power 10, but we know x squared. So right now let's get closer and closer to this x to the power 10. Moreover, we can express second power through the first one, because this is linear function, this is quadratic, this is a second power, this is the first power. So it's also really great to reduce a power. So right now the next step is to raise this x squared and this side to the power 2, and then we will have x to the power 4, which is closer to this x to the power 10. So you will understand everything, okay? So let's do it. So first of all, x squared we raise to the power 2, and we raise our right side to the power 2. So 1 minus 2x we raised to the power 2. What we have on the right side? On the right side we have x to the power 4. On the right side, we have a basic school identity. This is equal to 1 minus 2 times 2x and times 1 and plus 2x to the second power, according to a school identity. From here, we have x to the power 4, so the same beginning, equal to 1 minus 4x and plus 4x squared. And right now, one really tricky moment, because x squared equal to 1 minus 2x. So let's write it, but x squared equal to 1 minus 2x. And this expression helps us to reduce a power, so we will not have like square. So that's why instead of this x squared, we plug in 1 minus 2x right here at this place. So let's do it. So we have x to the power 4. We have x to the power 4 equal to 1 minus 4x and plus 4 times x squared. X squared equal to this expression, 1 minus 2x. From here we have x to the power 4 equal to 1 minus 4x plus 4 and minus 8x. Okay, plus 4 and minus 8x. So right now let's add the common expression from here. So we have x to the power 4 equal to 1 plus 4 equal to 5, minus 4x minus 8x minus 12x. So right now we have x to the power 4, and this is also extremely great expression for us. So right now we know about x squared, right now we know about x to the power 4, but just keep in mind that we need to solve it for x to the power 10. So this expression we need to find from here. So we need to find it because we call the substitution. This is equal to x. So that's why our next step, I hope you understand our next step, we need to erase this once more to the second power. Then we will have x to the power 8. So that's why our next step is to rewrite this expression and raise to the power 2 once more. So we have x to the power 4 equal to 5 minus 12x. So we raise once more to the second power and once more right here to the second power. So we raise this expression to the second power from both sides. Extremely important to raise it from both sides. Okay, let's simplify it. So we have x to the power 8, x to the power 8 equal to, right here this is our identity, 5 squared minus 2 times 5 and times 12x and plus 12x to the second power, 12x squared. Right now let's simplify it. So what do we have as a result? Right here we have x to the power 8 equal to 5 squared, we have 25, minus 2 times 5 times 12, 120x, and plus 144x squared. And right now let's look closely right here, because when we have this expression with square, we use this expression which helps us to reduce a power. So that's why x squared equal to 1 minus x. It's extremely important expression, and we write this expression once more, but x squared equal to 1 minus 2x. And we're going to plug in this, instead of this x squared right here, we're going to plug in 1 minus 2x, which simplifies us which simplifies that a lot. So let's do it. So we have x to the power 8 in the beginning equal to 25 minus 120x plus 144x squared, but instead of x squared, we plug in this one, 1 minus 2x, 1 minus 2x. Okay, let's simplify it. So x to the power 8 equal to 25 minus 120x plus 144 and minus 288x. So what do we have as a common expression? We have constants right here, and we have two variables. Okay, and we have two variables. Let's simplify this more. So we have x to the power 8 equal to 25 plus 144. We have 169 minus, right here we have 408x. And this is our x to the power 8. Okay, x to the power 8. So we already know x to the power 4, x to the power 2, and right now we know x to the power 8, but we have to solve it for x to the power 10. And how can we do this? Because when we raise x to the power 8 once more to the second power, we have x to the power 16. We don't need it. So the best way to solve it for x to the power 10 is to multiply x squared times x to the power 8. We know everything. So right now let's do this as a third step. So we have x squared times x to the power 8 equal to x squared. Right here we have it, 1 minus 2x. So 1 minus 2x. And the second parenthesis, x to the power 8 equal to this one, 169 minus 408x. So our last step is to multiply these two parentheses by each other. So as a result, what do we have? X to the power 10 we have right here. So x to the power 10 expression that we need. So 169 when we multiply parentheses by parentheses minus 408x minus 338x and plus 816x squared. So we can easily subtract this expression right here in the middle. So let's do it. So x to the power 10 equal to 169 minus, when we subtract it, we have 746x, not x squared, and plus 816x squared. And according to the same logic, but x squared equal to 1 minus 2x. Okay, 1 minus 2x. As you can see, we use this expression a lot, multiple times, which is really great because it helps us to reduce a power. So right now we're going to reduce this x squared in terms of the first power, 1 minus 2x. So we have x to the power 10 equal to 169 minus 746x plus 816 times, instead of x squared, 1 minus 2x, 1 minus 2x. Okay, so let's simplify this. X to the power 10 on the left side, x to the power 10 equal to 169, so the same beginning minus 746x plus 816 and minus 1632x. So we can easily add our common things, our constants, and our variables. So these variables are these constants. So as a result, x to the power 10 is equal to, when we add it, we have 985 minus, right here we have 2378 times x. And right now, the final moment, we have to go back in the beginning right here, because x equal to square root of 2 minus 1. Just remember this expression, x equal to square root of 2 minus 1. And right now, let's go back right here, square root of 2 minus 1. And here's our expression right now, this one. So we can write, but x equal to square root of 2 minus 1. And right now, instead of this x right here and right here, we plug in square root of 2 minus 1. And on the first side, we have expression that we exactly need, because when we plug in instead of this x, this expression, we have square root of 2 minus 1 to the power 10, yeah, equal to 985 minus 2378. And instead of x, we plug in square root of 2 minus 1. Our last step, let's simplify this real quick. So square root of 2 minus 1 to the power 10 is equal to 985 minus 2378 square root of 2 and plus 2378. So finally, our square root of 2 minus 1 to the power 10 is equal to, when we add it, we have 3363 minus 2378 square root of 2. So this is our square root of 2 minus 1 to the power 10. And right now, let's go back to the beginning right here. I'm going to write once more this question from the beginning. So as our answer to this question, because in the beginning our question looks like that: square root of 25, square root of 25 over square root of 10 minus square root of 5 and raised to the power 10. And we had in the middle of our solution, we had that this is equal to 3125 over square root of 2 minus 1 to the power 10. So we had it in the very beginning of a solution, so we have something like that. And right now we can easily plug in, instead of this square root of 2 minus 1 to the power 10, we can easily plug in this expression right here. We can easily plug in this difference, so we can write it as 3125 all over this one, 3363 minus 2378 square root of 2. Okay, and this is our answer to this question. Right now we don't have any tens power, we have only square root, so that's why maybe if you're interested in this, you can also multiply this expression in our denominator by the conjugate expression. Maybe if you're interested in this, you can multiply by this expression but with the positive sign. So that's why you can consider the denominator as a difference of squares, and maybe you don't have a denominator when you multiply by the conjugate expression. But this is up to you. You can also practice your algebra skills. You can also do it on your own. This is my answer. This is my solution to this question. This is my approach. Also write your solution your way. What do you think about this question? Maybe you have your way. How can we raise this square root of 2 minus 1 to the power 10? It's also really great to see it from your perspective. This is my way, according to x to the power 2, x to the power 4, x to the power 8, and then we get closer to x to the power 10, and then we go back to a substitution. This is my way. If you stand with it, you can also write your thoughts about it, write your response in the comments below. So thank you everyone for your time, thank you for being here, for watching this video. I really hope you enjoyed, and my main goal is to make math clear and understandable for everyone. And if this video is helpful in any way, if you learned something, I'll be extremely happy, and I want to say thank you for that, for watching this channel, for being here. A lot of students, a lot of teachers here, and I really appreciate it, and that you're here and you learn and you study math and you enjoy it, because it's extremely great from your side. It's extremely kind of you. If you leave your kind comment, if you leave a like, it's extremely great. I'm extremely happy with this when I see your amount of likes. It makes me extremely happy. So if the video is helpful in any way, I'm extremely helpful, and I want to say thank you for being here and for watching this video. So thank you everyone for your time. Take care of yourself. Have a great day. See you in the next videos.